Hello, friends. Today I have brought you a famous brain teaser called Monty Hall Puzzle. Suppose you are a contestant on a game show called Let's Make a Deal, hosted by Monty Hall. So, in front of you, there are three closed doors labeled 1, 2, and 3. So, behind one of the door is your prize, which is car in this case, and the other two doors have code behind them. You got to choose one door. So, after you make a choice, Monty knows what's behind each door, opens one of the other two doors, revealing a goat. He then gives you the option to stick with your original choice or switch to the other unopened door. So, what will you do? Will you stick to your original choice or will you switch to the other door? What should you do to maximize your chances of winning the prize or the car? So, the options are stick with your original choice, switch to the other unopened door. It really doesn't matter. Your choices are the same, the either way. Okay. So, what happens is if you see mathematically, if you switch the door, your chances to win the game are 66%. While if you stick with your original choice, then your chances are just 33%. So let's demonstrate this program in Java to figure out how it happens. Okay, so this is my Java program. So what I've done is I've simulated the condition and I'm running the same thing 20,000 times. The total game will be 20,000 so that I can figure out effectively what are the percentage chances to win the game. See, if I run the program and show it to you. So if I switch the door, my chances are more than 66%. But if I don't switch the door, I stick to my original choice, then the chances of winning are just 33%. So the number of times you run the program, you will come to know the probability in this case. So let's go to the Java program to see how we are able to simulate the game. So suppose I take this stay wins as the variable, which will be incremented if I don't want to switch. Switch wins is a variable which will get incremented if I switch the door. So number of games won by sticking to the original doors will be told me by stay wins variable. And if I wish to switch the doors, that will be counted by the stay wins variable. And I'm doing this program, I'm running this game 20,000 times. So I go inside the loop and I run the loop 20,000 times and I calculate the number in these variables. And I call a method called play game where I have implemented the game, like what I explained you that we have done in Java. So let's see. Let's go to the play game method. So I've taken this play game method as a Boolean. So it will return true or false depending on what the outcome is. So suppose I have this price position variable which will calculate which door my price or my car is there. So this will hold this price position variable. So how to do? See, this is a random program. I can't sit 20,000 times to run this program, right? So I will make use of this random, which is a very commonly used method in Java from the class maths. And as I know, the number of times I'm running it is, so the number of doors is 3. So I will use this value because I have 3 doors and I need to include 3 as well. So I'll use this and I'll give it as int because by default it gives me a double value, but I want an integer value, either 1, 2, or 3. So I'll make use of random method and it will generate me a number out of 1 to 3 and put it in the price position variable. Now, the second thing is the second variable is chosen door. So this is the door door number chosen by the user. Again, I randomly generated using the random method, and I have something. See, now there is no user intervention here. Everything is simulated. So I don't know if the chosen door and the price position is same. See, all these are randomly generated. I don't know. So I have to make the program more. I have to expand the program more to to consider all the conditions there. So suppose if the strategy is to switch doors, user decides, no, I want to switch the door. Then I have to take care of that also. And if the user says, no, I don't want to, then it's straightforward. So suppose the user says, I want to switch the door. Then I need to again change this variable chosen door, right? Initially, I generated a number. But then if the user wants to switch the door, I again need to figure out different things, which I'll just tell you in a few seconds. What are those different things I need to take care of before switching the door? But in either case, if the chosen door and the price position door are the same, right? Then I win. So it will return me a true, otherwise false. Now let's see what happens if the user decides to switch the door. See, first of all, what will happen? The host Monty reveals a door once I have chosen a door. So I have to take care of that also. Again, I will call this random method and I will put some value in the reveal door variable. Right? So, but I don't know if the reveal door is equals to the chosen door or it's equals to the price position door. I don't know because this is all randomly generated. But practically, when you're playing the game, the host will know what the user's original choice is or where the money is kept, price is kept. So obviously, the host will not reveal you that door. The host will reveal a different door other than the chosen door, the original chosen door, or the door which has the price. So we have to take care of that also. So if the reveal door is equals to the chosen door or the reveal door is equals to the price position, then I've not correctly selected the number. I need to select some other door. So if that's the case, I will again call this random method and again I will choose a reveal door and I will that's my reveal door which I am supposed to show to the user. So this is to figure out how I will be figuring out which door I need to reveal. Now once I know uh, the reveal door, I know the original chosen door, I have to figure out if the user switches the door, what should it be? So if the reveal door is number 1 and chosen door is number 2 or vice versa, then obviously the switch door, the other door which I switched to will be 3. See, one the host has opened, one I had originally thought. Then obviously it will be the third one. Similarly, if the reveal door is 2, chosen door is 3, then obviously I will switch to number 1 or I will switch to number 2 depending on the conditions. So the reveal door cannot be taken as the next choice and the original choice again cannot be taken as the next chosen choice. So the next chosen choice has to be different other than the original choice and the revealed choice. So depending on that, I have to again check it. So once I am able to figure out all this, I take that value and return that to the main program and it will increment the stay events variable if the user chooses not to switch. If the user chooses to switch, then this will be incremented switch wins. So depending on whatever is the outcome, depending on that, the respective variables will be incremented. Now, to calculate win percentage, see, basically I am trying to figure out my win percentage. If I stay with the original door, how much is my winning percentage? Or if I switch the door, then how much is my winning percentage? So that's what I'm trying to figure out, right? Because this is not a straightforward thing. There's a lot of maths involved in it when you play the game. So when I do this, what I do is whatever value I have divided by the number of total games played, which is 20,000 in this case, I calculate that percentage. So when I run the program and display that, I see that the percentage is 67% when I switch to the other door, and it is only 33% when I stick with my original choice. So, if you stick with the original door, you have less chances to win. While if you switch the doors, you have more chances to win. This is what is demonstrated by this brain teaser, and we did it using a Java program. If you have any questions with respect to this program, do write in the comment box and let me know your queries. If you like this program, like this puzzle, do like and subscribe. Thank you.